Okay, AP Econ students, this is your online lesson in elasticity. I'm going to start the presentation, go through it, and you should be in good shape. So this is from the unit Supply, Demand, and Consumer Choice. We are not going to cover consumer choice in this unit, just in case you're wondering. Hopefully you're as excited as this young man watching a New Jersey Nets basketball game. Yeah, elasticity. So remember, think of a rubber band. Elasticity shows how sensitive quantity is to a change in price. So when the price changes, how responsive is that change in quantity? So if you drop the price 10%, do you sell a million more, 1,000 more? The elasticity shows the sensitivity to that change. Obviously, inelastic would be like a really firm rubber band that's hard to move. An elastic would be like a very easy one that you can stretch. So there's 4 types. We've gone over elasticity of demand in class. Elasticity of supply will not be on the test, but I'll talk to you about what it is briefly. And then you will have a question or two on cross-price elasticity, which tells us whether something is a substitute or a complement, and income elasticity, which tells us whether something's a normal good or inferior good. So elasticity of demand is a broader category. Cross-price elasticity is much more narrow, right? We're specifically looking at whether two goods are substitutes or complements. With income elasticity, we're looking whether a change in income means it's a normal good or inferior good. So we've talked about those before. Now we can actually measure them through these formulas. A little review, elasticity of demand is the measurement of consumers' responsiveness to a change in price. So when the price changes, what happens to quantity or quantity demanded? There's some reasons about why it's done. Firms will use it to help determine prices and sales. The government decides how to tax, which we saw through our example with tax. If the demand curve is much more inelastic, the burden goes much more on consumers. So in elastic demand, you go to the store looking for milk, it's 80 cents. The woman's very happy, she's like, I'm getting milk. She goes to the store, it's $2.40, but she still needs it. So the change in price did not necessarily change her ability or her want to get milk. So it's insensitive, inelastic, IN. Inelastic is insensitive to a change in price. It looks much more like an I. You see that graph there. So the change in price in that example went up 20%, but the quantity only dropped 5%. So this would be things you need a lot more. Okay, so you can see the examples below. We talked about those in class. Some characteristics, doesn't have to be all of them, but it could be a necessity, or it could have few substitutes like gasoline. A small portion of income, like toilet paper is not a huge portion of income, but you do need it, and it's required now rather than later. And then how you figure out the elasticity coefficient. So if you're looking at a good and you can't tell from a graph, like you see how steep that inelastic demand is, it's pretty obvious. But if you're not sure whether the curve is inelastic or elastic, you can find the elasticity coefficient. So you find the percent change in quantity. So in this case, it's 5. So it would be down 5, so negative 5, over a change in price of 20. So we know that's less than 1, right? That's 0.25. And it's negative, but we make it absolute value. So it doesn't matter that it's negative. It will matter later for cross price and income elasticity if it's negative, but for this, it's absolute value. So it's either 0, 0 to 1, or 1 or greater than 1. Those are your choices. So 0 could be elasticity coefficient, anything like 0.25, 0.33, 0.56, right? So that would be inelastic. Inelastic, less than 1. 1 would be unit elastic, and greater than 1 would be elastic. So elastic demand, you go to the store, cola is $1, you're very excited. You go to the store, it's $3, nope, I'll buy something else. All right, so soda, boats, real estate, it looks much more flat. It is sensitive to a change in price with elastic. So many substitutes, right? So cola, you can go get Gatorade, you could go get juice, you could drink water, there's lots of substitutes. Or it's a luxury like a boat or a house, you don't need it right away. I mean, housing obviously is something you need, but if you're living in an apartment, you may not buy a house if prices go up. Large portion of income, same thing there with boat and house. Plenty of time to decide. And then when you do the elasticity coefficients, greater than 1. So in this case, in the graph, the percent change in quantity is minus 15 over positive 10. That's greater than 1, right? And you absolute value it, so it's greater than 1, therefore you know it's elastic. So here's some examples. take a second to pause the video and try to answer whether beef, gasoline, real estate, medical care, electricity, and gold are elastic or inelastic. Pause it now. Okay, have you unpaused it and done it? Great. Okay, so let's look at the answers. So beef is elastic, plenty of substitutes. Gasoline, not a lot of substitutes. Real estate takes lots of time, large portion of income. It's elastic. Medical care, there's no replacement for that, right? Electricity, similar. There's very few replacements. In gold, lots of replacements. So there's elastic and inelastic. We've talked about this in class, but what about the demand for insulin for diabetics? That is an example where the coefficient is 0, and it is perfectly inelastic. So you can see it's a vertical line. So no matter what the price, you need insulin if you're diabetic, and there's not more diabetics in a snapshot in time, so the quantity demanded stays the same. Okay. What if the coefficient is exactly 1? So what if the percent change in quantity demanded equals the percent change in price? So it's 10 and 10. In that case, we have what's called unit elastic, where the coefficient is 1. So if the coefficient comes out exactly to 1, which none of these examples on this page are, it would be unit elastic would be the term. One of my favorite memes of all time is this boy riding a bike that looks like a unicorn. So haters gonna hate. They're always hating on us in AP Econ. We're gonna grind through. Total revenue test. Okay, so this is an easy way. Instead of finding elasticity coefficient, you can actually find out through the total revenue test if something's elastic or inelastic. So for example, if the price goes up and total revenue goes down, or if the price goes down, total revenue increases, that is elastic. So if they go in opposite directions, so if you stand up, go ahead, stand up. I'll wait. So if you put one hand in the air, straight up, and then the other hand in the air, those are both going in the same direction, similar to an I, or put them both down, going in the similar direction like an I. That helps you remember it's inelastic, because as price increases, total revenue increases, or as price decreases, total revenue decreases. Okay, and total revenue, as you can see in the red parentheses, is price times quantity. Unit elastic would be the price changes, either increase or decrease, but total revenue doesn't change. That is unit elastic. So those are the three options here. So answer this question. If demand for milk is inelastic, what will happen to expenditures, which is like the sales of milk, if the price increases? So if milk is inelastic, right, that means as the price goes up, we would expect total revenue to also increase. Here's an example we'll do. So when we have 2 points, and this would be like what you could see in a test to figure out total revenue test, is between A and B on this curve elastic, inelastic, or unit elastic. So you could find the percentages if you wanted and do the elasticity coefficient, or a much easier way, you can see that the price is going down from A to B, the quantity is going up, right? So you find total revenue at A, so 10 times 100, so look at point A, see how it's $10 times 100 is 1,000 in total revenue, and then go to point B, and do 5 times 225, which is 1125 in total revenue. So the price went down and total revenue increased. If you put your arms up, those are in opposite directions, so you know it's not inelastic. And because total revenue is not unchanged, it has changed, you know demand is elastic. So you see in the bottom right, there's the elasticity coefficient formula. You could do it that way if you want, but it seems like a lot harder, so use the total revenue test. Oh man, haters are gonna hate. It's a great one, isn't it? We're almost done. Okay, this is the one that's not going to be on the test, so feel free to skip through it if you want. But you do need to know it at some point. So elasticity of supply is a lot like demand. It's just how sensitive producers are to a change in price. It is based on time limitations. So if you think about it this way, if you go to the store to buy milk and the price has gone up, you might still need it. But if you go to buy cola, ooh, that's awkward. If you go to buy cola at the store and the price goes up, you can make a decision right away. So the elasticity of demand can be almost instantaneous. With supply, producers actually have to change something based on what happens in the market, right? So if they need to produce more of an item, right, it's going to take them a while. They can't just go to their warehouse and produce it. They have to actually go through the process of production. So it's still percent change in quantity or percent change in price. What this means is most goods have inelastic supply in the short run, right? Because they can't really change their amount due to a change in price in the short run because they have to go through the process of production. In the long run, they're much more sensitive to a change in price. So if the price changes for whatever reason in the market, they can't really change their quantity in the short run because they have what they have. They have the inventory they have. But if a shoemaker in the long run is like, "Whoa, the price is going up, we want to make more," they can do that. So it becomes much more elastic in the long run. That's a big thing to remember here. All right, let's go on to the last two. Here are the two you need to know on the test, and they're special cases. So cross-price elasticity and income elasticity are different than the other things we've done so far, but similar in concept. So cross-price elasticity has one purpose only, and its purpose is to show us whether goods are substitutes or complements. So you have two goods, you have good A and good B. You want to know, are they substitutes or complements? Are hamburgers and hot dogs substitutes or complements? Or skis and ski boots substitutes or complements? You may be able to figure that out just logically, but there's a way to use a formula to figure out the cross-price elasticity of demand. And it shows how sensitive they are to the change in price of another good. So if ski boots goes up in price, how sensitive are skis to that change? Okay? So that's specifically what we're doing. It's really important you do not absolute value the answer that you get from this equation. You have to know whether it's negative or positive. Okay? So it's percent change in quantity of product B, whatever product B is, over the percent change in price of product A. So if the price goes up of one product, you put the change in quantity of the other product on the top of this equation. Okay, and you need to use negatives. So for example, the price increase is 20% of bikes. So that goes on the bottom, and that is a positive, right? So we put 20% bikes on the bottom, and the quantity of bike helmets decreased 15%. So that's product B, and we put it on top, we put negative 15. So we would have negative 15% over positive 20%. So we would have negative 3/4 essentially, right? Great, or negative 0.75. And if the coefficient is negative, it shows us they are complements to each other. Now we probably knew bike and bike helmets was complements, but now we know how much, how close to 1 it is, shows us how much they are complements to each other. If we did it the other way, if we had two goods where a price went up and then the quantity went up of the other one, it's a substitute, which kind of makes sense if you think about our logic. If hamburgers and hot dogs are substitutes, if hamburgers went up 20%, we would expect the quantity of hot dogs to increase because people would go from hamburgers to hot dogs. So they would have a positive. Okay? So it's important that you practice this, and I'll give you some practice in class, but you will also need to remember that formula. Percent change in quantity of product B over percent change in price of product A, and that you need to figure out whether the answer is negative or positive. That's the key. Okay? Last one. Income elasticity of demand. The income elasticity is specific. It's different than cross price, and it's another specific one, and it's showing us how sensitive a product is to a change in income. Basically, whether something's normal or inferior. So remember, when we change our income, we want to figure out if a good's normal or inferior. We know whether that good is bought more or less. So percent change in quantity over percent change in income. Again, we need to know whether it's negative or positive. Do not use absolute value. Okay? So it's really important here. So if the income increases 20%, so we put that on the bottom, and the quantity decreases 15% of a good, so that's a negative 15 on top, then the good, it comes out to negative 0.75. We know it's an inferior good, which logic tells us from our demand, we know this. When our income goes up and we buy less of something, it's inferior, right? Spam, fruit rings, things of that nature. So in this case, if the coefficient is negative, it's inferior, and if it's positive, it's normal, okay? So if income falls 10%, that example on the bottom, so negative 10 on the bottom of this equation, and quantity falls 20, so negative 20 on the top, we get 20 over 10, right, which is 2. That's a normal good, okay? All right, that's it. Good luck. You should be fine. Just remember both this formula and the other one, and you'll have some practice in class. You'll just have a couple questions about that, and you should be good. Okay, you can email me with any questions. I will be on email this week, and I can answer it to give some clarification.